Alright, what we're going to talk about today is Pythagoras' theorem. Now, Pythagoras, he was this big mathematician guy. He's a pretty smart dude. There's a picture of him there. Look at the size of his cranium. This guy's smart. Anyways, legend goes is that he was sitting in his bathtub trying to figure it out exactly how to come up with a formula that would calculate what the long side of a triangle, of a right angle triangle, would be. That's called, of course, we know it's called the hypotenuse. Well, legend goes that Pythagoras came up with the formula a squared plus b squared equals c squared in relation to a triangle where c in the formula always stands for the long side of the triangle or the hypotenuse. Now the story goes is that he had what they called a eureka moment, or just a flash idea, and he was in his bathtub and he shouts out eureka and jumps out of the tub and runs down the street shouting out eureka and then the name of the formula, a squared plus b squared equals c squared. Anyways, here's how you solve a squared plus, or use a squared plus b squared equals c squared in an actual equation. You will quite often be given a formula to solve for the long side of a triangle where the a side is 3, the b side is 4, and the c side is the unknown. So you need to solve for c. Well, using our formula, a squared plus b squared equals c squared, we pump in the 3 squared plus the 4 squared, and it's going to equal our c squared. Now, according to BEDMAS, we have to do our squares before we do our addition. Now, square stands for multiplying the 3 by itself twice, not 3 times 2. So 3 times itself twice, or 3 times 3 is 9, plus 4 times itself twice, 4 times 4 is 16, equals c squared. Now we can do our 9 plus 16, which is 25, equals c squared. Now, I still haven't solved the equation though, because I've solved for c squared, but I haven't solved for c. So in order, what I have to do is I got to somehow get rid of that squared sign. Well, in order to get rid of a squared sign, I could do the opposite of a squared sign to that side of the equation, which in this case is a square root. Now, according to math, because math is a teeter-totter, if I threw on a squared sign onto one side of the equation, and if I just left the 25 as it is, I've just added something to that teeter-totter. That teeter-totter is going to tilt. So the rule is, whatever I do to one side, I do to the other. So I'm going to put a squared sign over here. This keeps our teeter-totter even or equal. Now, the square root and the square sign end up canceling each other out. And the result of that is that it gives me a c on this side of the equation, which is what I want. I want to solve for c. That's my goal. That's my objective. I've now completed the right-hand side of the equation. That side's done. All that's left is to finish off the left-hand side. And I take the square root of 25. I want to take the square root of 25, pump it in my calculator, and I get 5. So, in our triangle, a squared plus b squared equals c squared, where a is 3, b is 4, c will end up being 5. Now, what we can do is, if we're given the equation a squared plus b squared equals c squared, and they gave us the answer for c, but we didn't know exactly what b was. We had to end up solving for b. We knew we had a 3, we knew we had a 5, we didn't know what we had for b. Well, I'd pump this into the formula, and I'd end up with a squared being 3, so 3 squared plus a b squared, I don't know, which is equal to 5 squared. Let's solve. 3 squared is 3 times 3, which is 9, plus the b squared equals 5 times 5 is 25. Now, again, my objective now is to solve for my unknown. I have to solve for my b. My eventual goal I want b by itself. b equaling a singular number, so b equals something. Well, in order for me to go from b squared down to b, I first of all got to get rid of this plus 9. Well, the way to get rid of a plus 9 is to throw the opposite of a plus 9 onto that side of the equation. In that case, that's a minus 9. Well, if I throw a minus 9, I've now tilted my teeter-totter, remember? It's now unbalanced. So whatever I can do to one side, I have to do to the other. So I put a minus 9 over here. Well, the minus 9 and the plus 9 cancel each other out, and I'm left with b squared. That side of the equation. On the right side of the equation, I've got 25 minus 9 gives me 16. Now remember, again, I'm trying to solve for b. I've got b squared, but I want to get down to there. So in order to get rid of the b squared, I can throw on a square root onto that side of the equation. But whatever I do to one side, I have to do to the other. So now I've got the square root of b squared equals square root of 16. Well, the square root and the square cancel each other out, leaving me with my b on that side of the equation. Done. Left side's done. Now I just have to solve for the square root of 16, which I figure out as 4, which we knew all along. There you go. That's Pythagoras' theorems.